Right, we're going to do try 13. This is the second questions from the SLS lesson 1 on the topic of quadratic functions. Right, this beautiful tunnel is taken from this website. Right, it's a very, I use this tunnel because it actually represents a real life model of how we can apply quadratic functions onto our daily lives. So the width need not be 3 meters and the height need not be 2 meters. Right, I'm just using this picture as an example in order to solve these questions. Right, in one of the videos, I actually show you guys how you can actually factorize a quadratic functions in different ways. Factorizing it using the intercept values, where we have seen it in try 12. So in this try 13, right, what we are going to represent the quadratic function, it's not in the x-intercept format, but rather in the completed square format, right? So if you're not too sure, right, what it means by the completed square format versus the intercept format, then please refer to the video that I have done, right? The title is different, I think, expressing quadratic functions, factorizing quadratic functions in different ways. All right, so let's look at this question here. So this is a N-shaped curve, meaning what we are dealing with is a maximum point. It's a maximum point, right? So there are a few things here. So we have a maximum point here. And then we have the x-intercepts here. Okay, this one will be 3, 0. And this will be 0, 0, right? So if you look at the maximum point, how do we find the maximum point? Right. So the line of symmetry will pass through your maximum minimum point. And to find a line of symmetry, it's just taking your two x-intercepts, divide by 2. So here, your maximum point will be 1.5, 2, right? Right. So how can you fit your 1.5, 2 into your quadratic functions? So if you were to recall, right, because if you're dealing with a maximum point, we're actually dealing with an N-shaped curve. So we're dealing with the maximum point. So therefore, your A is less than 0. And then your minimum point is equals to H, K, right? Okay, if you do not understand how I get this minimum point equals to H, K, please refer to the video, on quadratic functions, factorizing quadratic functions in different ways. All right. So we're going to compare this minimum point with what we found earlier on. Which is equals to 1.5, 2, right? Right. So if you substitute this point into your quadratic function, your answer will be y equals to a bracket x minus 1.5 squared plus 2. Right. And we are not done yet because we still have this unknown constant a. So there are two x-intercepts that you can use to find the constant a. You can either use 0, 0 or 3, 0. So obviously, I would prefer to use 0, 0. Right, both of them will give you the same answer for the constant a. So I'm going to okay, wait. Let's be more systematic. I'm going to call this equation 1. And I'm going to call or say sub 0, 0 into equation 1. I would have a bracket 0 minus 1.5 squared plus 2 equals to 0. So a bracket, okay, my 0 minus 1.5 squared, you can just simply use a calculator to evaluate it so that we don't have to keep writing 0 minus 1.5 squared. You know what I mean? And that gives you 9 over 4. So it's a times 9 over 4 equals to negative 2. So a will be negative 2 divided by 9 over 4 and gives you negative 8 over 9. So therefore, your quadratic function will be y is equals to negative 8 over 9 bracket x minus 1.5 squared plus 2. This is how you solve the first part. All right, so in part 2, we're asked to find the height of the arch when its width is 1 meter. So what does the width of the arch mean? So if you look at the diagram, right, this is your arch. This guy is your arch, right? So the width will refer to, it can be this width that you're talking about. Then the height would means the height in this case will be slightly more than probably how many? 1.5 meter, right? It can also, the width can also refers to from here to here. This from here to here, that will be your maximum width lah, which is 3 meter. You understand what I'm saying? Or it can be from here to here. So at different with different width of the arch, you will have different heights, right? If that is the width you're talking, then this is the height that you're referring to. And if you're talking about the width from here to here, then obviously the height is 0 lah, right? The height is 0, right? So the question says that what happened, asks you to find the height of the arch when the width is 1 meter. So I'm going to use the middle point, the line of symmetry as a guide. Line of symmetry as a guide. So which one is a line of symmetry? This one is a line of symmetry. Here, this guy is a line of symmetry. So if you use that line of symmetry as the guide, right, 1 meter means that here to here will be 0.5 meter. Oh my god, what am I talking? Here to here is 1.5 meter. So 0.5 will be roughly agak-agak somewhere here. So here to here will be 0.5. Okay, let me erase this. Very confusing. Too much things there. Here to here, another 0.5. Okay? Okay, I'm going to erase this guy since you know that what I'm talking already. So, right. So to get 1 meter for the width of the arch to be 1 meter, so here to here, 0.5 plus 0.5 is 1 meter lah. Then the height would be this much here. This much here will be your height. This is the height that you need to find. Okay? Do you understand? Yeah. Okay. You have to measure the width of the arch from your line of symmetry because it's symmetrical. Right. The tunnel that you're saying is symmetrical. Right. You can't, okay, you can't say that the width is from here to here 1 meter. Right, that's not correct. Okay, that's not correct. So this is not correct. So let's erase off the not correct one. Right. Okay. So what do we need to do? So what we need to do is that, remember the formula that we found earlier on? The formula we have found earlier on is the formula for your quadratic function, right? And this x represents the horizontal distance from your origin. Okay, this x here represents the horizontal distance from the origin. Okay, so in other words, if let's say from so the distance that I need to find will be from here to here. In order to substitute into this quadratic function, right, I need to find the right values for x. I cannot sub x equals to 1 meter. Okay, because from this diagram here, x equals to 1 meter is the width of your arch. It's not the horizontal distance from the origin. All right, so how much would that distance be? Okay, so this distance here will be 3 meter. 3 meter is the whole width, right, of the arch. You minus away 1 meter and you divide by 2. Gives you 1 meter. So therefore, what I'm saying is 1 meter. This is 1 meter. This is another 1 meter. So add up to be 3 meters. 1 plus 1, 2, 2 plus 1, 3. So hence, what you're substituting is that you're substituting your x to be 1 meter into equation 1. To find your y, y is the height of the arch. So y is equal to negative 8 over 9. 1 minus 3 over 2 squared plus 2. And if you use a calculator to work it out, and you will get the answer as 1/7 over 9. So therefore, the height of the arch. Okay, no cursive writing, write properly. The height of the arch is 1/7 over 9 meter. So here we are. All right, let's come to the last part of the questions. Happiness is when we finally come to the end of the questions. Okay, so we need to decide whether it is possible for a boat that is 1 meter wide and 1.8 meter tall to navigate through the underpass. Yeah. Okay, so if you want to build a what they call that, underpass, right? Yeah, you have to make sure that measurements are correct, accurately presented to the public, so that so the people will not be trying to navigate through the underpass, in a huge boat, the kind of thing, get stuck and then that's it, right? Okay, right. So we need to do some calculations. Okay, so how do we calculate it? Decide whether it is possible for a boat that is 1 meter wide and 1.8 meter tall. Okay, so just try to draw a boat. I'm not really very good at it, but we can try. So 1 meter wide. So supposing, because this is symmetrical, the tunnel is symmetrical, so we assume that the boat is traveling in the line of symmetry. So this boat will be 1 meter wide here and 1.8 meter tall. Well, I think it has to be bigger, right? Something like that. Is it? Okay, I'm sorry, I can't really draw a boat. Okay. Right. Oh my goodness. So how do we go about 1 meter wide? Oh, okay, great. So what we need to do is that we need to, isn't it what we have found in part 2 already? 1 meter wide and 1.8 meter tall. So in part 2, I thought we are supposed to find the height of the arch when the width is 1 meter. Right, when the width of the arch is 1 meter. So in part 2, oh, all right. So in part 2, so we found that we found that when the width of the arch, it's 1 meter, the height of the arch, it's 1/7/9 meter, right? So that will be the maximum height, okay? That will be the maximum height. So anything more than that means you cannot navigate through the underpass. So if you have a boat that is 1 meter wide and height 1.8 meter, so obviously 1.8, it's more than 1/7/9, right? 1/7/9, if you use your calculator to work this out, 7 divided by 9, it's 0.77, blah, blah, blah. So this one is approximately 1.78 meter. Right, so obviously 1.8 meter, it's higher than 1.78 meter. Right, so quite obviously this boat can't go through. Okay, so the diagram is wrong. Okay, so this is how we explain on. This is how we explain. In part 2, we found that when the width of the arch is 1 meter, which is the width of your boat, the height of the arch is 1/7/9 meter. So since 1.8 meter, it's more than 1/7/9 meter. Okay, the boat. So sorry. Okay, so sorry to the boat. The boat cannot navigate. You get stuck. I don't think you even get stuck. You can't even go through it all. The boat cannot navigate through the underpass. Okay, so this is how you solve the last part of the question, and it's happiness because it's just so short. There's no calculation. It's just some logical explanation. And that's it. We have come to the end of try 13. Okay, thank you.